Fred Williams, Frugal Finance. Remember long ago, I said, wait patiently and I'll get the answer for you. We were discussing forwards versus futures. And I said, be patient. I'll get the answer to you. Well, here's the answer. Maybe this will clarify. We have forward versus future interest rates as opposed to commodities. So we're going to look at this in terms of the investment side. The Eurodollar future contract is similar to a forward rate agreement, and I probably mentioned that. I probably threw in futures in the conversation with forwards. In that, it locks in an interest rate for a future period. For short maturities, up to a year or so, the two contracts can be assumed to be the same. And the Eurodollar future interest rate can be assumed to be the same as the corresponding forward interest rate. For longer dated contracts, differences between the contract become important. Compare a Eurodollar futures contract on an interest rate for the period between T1 and T2 with an FRA for the same period. The Eurodollar futures contract is settled daily. The final settlement is a time T of 1 and reflects the realized interest rate for the period between T1 and T2. By contrast, the FRA is not settled daily. And the final settlement, reflecting the realized interest rate between T1 and T2, is made at T2. There are therefore two differences between a Eurodollar futures contract and a FRA. These are the difference between Eurodollar futures contract and a similar contract where there is no daily settlement. The latter is a forward contract where a payoff equal to the difference between the forward interest rate and the realized interest rate is paid at time T of 1. The difference between a forward contract where the settlement at T of 1 and a forward contract where there's a settlement at T of 2. These two components to the difference between the contracts causes some confusion in practice. Both decrease the forward rate relative to the futures rate, but for the long-dated contracts, the reduction caused by the second difference is much smaller than that caused by the first. The reason why the first difference, daily settlement, decreases the forward rate follows from the argument in are forward prices and fewer prices equal. Suppose you have a contract where the payoff is R of M minus R of F at time T of 1, where R of F is a predetermined rate for the period between T1 and T2. And R of M is the realized rate for this period, and you have the option to switch to daily settlement. In this case, daily settlement tends to lead to cash inflows when rates are higher and cash outflows when rates are low. You would therefore find switching to daily settlement to be attractive because you tend to have more money in your margin account when rates are high. As a result, the market would therefore set R of F higher for the daily settlement alternative, reducing your cumulative expected payoff. To put this the other way around, switching from daily settlement to settlement at time T of 1 reduces R of F. To understand the reason why the second difference reduces the forward rate, suppose that the payoff of R of M minus R of F is at time T of 2 instead of T of 1, as it is for regular forward rate agreements. If R of M is high, the payoff is positive. Because rates are high, the cost to you of having the payoff that you receive at time T of 2 rather than T of 1 is relatively high. If R of M is low, the payoff is negative. Because rates are low, the benefit to you of having the payoff you make at time T of 2 rather than T of 1 is relatively low. Overall, you would rather have the payoff at time T of 1. If it is at time T of 2 rather than T of 1, you must be compensated at a reduction in R of F. Analysts make what is known as a convexity adjustment to account for the total difference between the two rates. One popular adjustment is forward rate equals futures rate minus 2 times standard deviation T of 1, T of 2, whereas above, T of 1 is the time to maturity of the futures contract, and T of 2 is the time to maturity of the rate underlying the futures contract. The variable R is the standard deviation of the change in the short-term interest rate in 1 year. Both rates are expressed with continuous compounding. A typical value for the standard deviation is 1.2% or 0.012. Consider a situation where the standard deviation is 0.012 and we wish to calculate the forward rate when the 8-year Eurodollar futures quote is 94. In this case, T of 1 equals 8, T of 2 equals 8.25, and the convexity adjustment is 1/2 times 0.0122 times 8 times 8.25 equals 0.00475 or 47.5 basis points. The future rate is 6% per annum on an actual 360 basis with quarterly compounding. This corresponds to 1.5% per 90 days, or an annual rate of 365 divided by 90 equals 1.015 equals 6.038% with continuous compounding in an actual 365-day count. The estimate of the forward rate given by equation 6.3 therefore is 6.038 minus 4.75 equals 5.563% per annum with continuous compounding. The table below shows how the size of the adjustment increases with the time to security. So we have maturity 2 years, convexity 3.2, and it goes all the way up to 73.8. We see from this table that the size of the adjustment is roughly proportionate to the square of the time maturity of the futures contract. Thus, the convexity adjustment for 8-year contract is approximately 16 times that for a 2-year contract. Reread it, then reread it, then reread it. Brad Williams, Frugal Finance. Welcome to finance.